Hi there. I just wanted to make a really quick video showing how to do cell size estimation. It's just a common question that students have, and it comes up not only on this quiz, but again at the midterm for sure. So what you'll see in these problems is you'll see a field size. I'm going to draw here. This is like the view in the microscope here in yellow, and then you have cells that are inside of that. So the cells inside, you need to know what cell you're looking at. So in this particular problem, you're being asked for the size of the bacillus. So that's the rod-shaped cell. But you need to double check, because if it's Coccus, then you're looking at the circular cell. So once you've decided what you're using, so in this case, we're using bacillus. So we're looking at these, the rod shape. So I'm always looking at length when I look at bacillus. We don't focus too much on width because that's pretty consistent. Coccus is a circle, so it doesn't matter. And what I want to think about is how many cells, if I could line them up end to end, fit across. So these are really, really poorly drawn rod-shaped cells, so bear with me. So maybe I'm going to have 1, 2, 3, 4, 5. So maybe 4 to 5 cells across. We'll just pick a nice easy number. We'll probably pick 5. And then all I need to do here, it's actually much simpler than you might think, because often students start thinking about calculating field size. But you don't need to in this particular kind of problem, and this is the most common one we see. You're already given the field size. That's the magnification. Here's the field size. So very, very few steps. You actually just need to do a simple division problem. If I can, there we go. So I just need to take the field size. Now think about like if you were looking at your living room and you wanted to see how big your living room was, and maybe you wanted to buy some new furniture, or someone's giving you something to see if they want to fit. So you just need to know how big that space is, and that's a constant. Your living room is always the size it is, right? You might want it bigger, you might want it smaller, but that is the size that it is. So that is a constant. And then you just have to then calculate how many cells fit across. So we would just simply write, and just to make it easier here, I'll make sure I write cells, or not easier, but just clearer. So I just then simply need to take the 0.2 and take my calculator and divide it by 5. So in this case, I'm going to get 0.04, and I need to look at my unit. So my units here are millimeters. Now, I could be done if that's all that's being asked for here. So here, then I have to estimate how many cells fit across. So we said about 5. Remember, if it's the Coccus, those circles, it would be a lot more. And then for the final answer here, I now need to convert this to micrometers. So I need to go from millimeters to micrometers. So some of you are just thinking, oh no, not metrics again. The good news is in Microlab, you're almost always going from millimeter to micrometer. That's about all we do. So all you really need to remember is that you just need to go 3 spaces to the right. And I don't know if I have quite enough space here, maybe. Let's see. I'm going to go 1, 2, 3. Okay, and that's almost always what you're doing. So I'm going to end up with, and of course this is not a real bacterial cell, I'm going to end up with 40 micrometers, just simply going 3 spaces to the right. That's almost always what you're doing. So the 2 hardest things here is just paying attention to which cell type you want. So remember we said the bacillus, and then remembering that you probably need to convert it to micrometers in most cases. Don't confuse this with the problem types where you have a table and you have to calculate field size. That's something we generally only do once, right? Because again, going back to the living room analogy, you only measure your living room dimensions once, maybe later on if you forget them in a few years, but it doesn't change. So once you have filled in a table with field size, you don't have to keep doing that every time you calculate cell size. So we kind of treat it like that with these problems because we're just giving you this constant. This is how big it always is under the microscope in this yellow area here. It's always 0.2 across. Okay, so that's always going to be 0.2 across. And this is nice thing about online is we can't do that on the real microscope. So it's always that space. So it's just a matter of figuring how many cells go in, and you just divide it by the number of cells. And I know when I work with students in lab, they're like, that's it? Because they think they have to do a lot more, and you really don't. So that's what most of our problems for cell size estimation are going to look like. So just carefully read the problem, and you should be good. All right, I hope this helps. Please email me with questions on this, and keep reaching out. I really appreciate it.